Okay. Yes. So good afternoon, everyone. Good afternoon once again. We will start this topic, which is angular momentum, and I hope that all of you understood all the concepts before this. Yes or no? Right? हाँ या ना? Because last class में हम लोगों ने problem भी discuss किया था, तो थोड़ा बहुत तो concept clear हुआ होगा. Again, right? With more practice, the concept would be better. Okay. Now, when you talk about angular momentum, right? So I can relate it somewhat with linear momentum. Yes or no? Right? हाँ या ना? Every one of us have a basic idea about linear momentum. Class 9 में पढ़ा था. Then पिछले कुछ chapters में पढ़ा था. Yes or no? Raise your hand. Yes or no? थोड़ा बहुत तो पता है ना? What is linear momentum? Mass into velocity. Right? Yes sir. पता है sir. Okay. Very good. Okay. So before talking about angular momentum, right, and the topics related to that, let us have a recall test. Okay, let us have a recall test. Let us see how many of you have actually watched the videos, because I've told you, right, last class that please watch the videos of this topic. Hai na? Okay. So first one, changing the axis of rotation must change moment of inertia. True or false? This is prerequisite, right? This is something that we have already studied. Super easy. Okay, very good, Snigdho. Only one answer. What about others? Okay, what I'll do is I'll just launch a poll. Okay, right? You just select ABCD. Select ABCD. Just select. Jaldi jaldi. Question one ka. Only one. Okay, just select it. Just select it, right? So that I can get to know na. Again, jaldi select it. Okay. Jaldi. You can select, so you just select, use the poll, na? You can just use the poll, right? Okay. So only 10 of you can see the poll, you just have to select, right, guys? So I assume that only 10 of you are answering. Okay, only 10 of you are answering. Okay. The answer is, we will see. What is the answer? We'll see. Okay. Chalo. Next. Okay, what happened? Just give me a minute, guys. Something happened. Okay. Right? Next. So torque is defined as. Tell me. Again, ABCD. Jaldi. Torque is defined as. काफी हम लोगों ने देखा था लास्ट क्लास में, राइट? काफी देखा था हम लोगों ने लास्ट क्लास में. Okay, 13 students answered this. Okay, right, I guess 13 answered this. Okay, next, third one, choose the correct option regarding this circular motion, है ना? बताओ, third one. Only one answer I got till now. Think about it. This is based on the direction of vectors. Only 5 answers till now. 1 minute. I'll wait for 1 minute, right? 30 seconds is over. Tell me. Only 7 answers. 7 students answered. 8. Jaldi karo. 9, 10, 11. Okay, very good. Times. Okay. Okay, time's up. Right? 11 students. Okay. Next, fourth one. One, on a frictionless surface, there cannot be pure rolling. On frictionless surface. ये तो कल ही हम लोग डिस्कस किया था. Yes or no? ये कल डिस्कस किया था हम लोगों ने. तो इसमें सबके आंसर्स सही होने चाहिए. Only 2 students answered. Guys, जल्दी बताओ. Only 10 answers. Okay, right. 11 answers. Yeah, ये तो simple था. Fourth one was, I was expecting more answers. Okay. Now, next, last one. This is last one. This is last one. Only 3 answers. Eight answers. Guys, 20 out of 29, only 8 answers. That is something, but that is something not acceptable, right? Think about it, na? Simple, hai na? We have solved problem based on these simple concepts. Okay, let us check the answer, right? I'll stop the call. Let's check the answers. Okay. Okay, chalo. Right. So when you talk about this, first is false. Okay. First is false. Kaise? Wait. Yeah. So if you see this first one, change the axis of rotation, must change the moment of inertia. The answer lies in the must, right? Okay. Now I'll give you one example. Last class also we discussed one example. When you talk about sphere, right? If you take this axis or this axis, tell me, will there be any change in its moment of inertia, or will it be 2 by 5 mr square only? Tell me. समझ में आ रहा है सिंह दो? Yes or no? Very basic, yes or no? So because of this must, right, you made mistake. Got it? Because of this must, you made mistake. So the answer is false. Because must जरूरी नहीं है ना, है कि नहीं? Depends on which axis you're talking about, depends on which kind of construction you're talking about. Then second is B, R cross F. ये तो simple था. Now third one is actually B. Why? Because we know R cross B is equal to what? Tell me. R cross B or V cross R is equal to what? Omega. Right? Yes or no? Direction will be same, na? Tell me. Right? Yes or no? Right? Now tell me, if you talk about angle, if it is 0 degree or 180 degree, right? If it is 0 or 180 degree, it will not be 0, na? It will not be 0, right? So the answer is B. Okay. Fourth one, true. Right? Fourth one, true. We know that. We have discussed in last class. And fifth one is F1D. Now, क्वेश्चन पढ़ लो यार तुम लोग, क्वेश्चन पढ़ लो. तुमसे पूछा क्या गया है? वर्क बाय फोर्स F1 नेटवर्क में पूछा गया क्या तुमसे? टेल मी, नेटवर्क में पूछा गया? जो तुम लोगों ने सी आंसर दिया, नेटवर्क में पूछा गया क्या? नो राइट, है ना? तो अगर तुमसे नेटवर्क में पूछा ही नहीं गया है, वर्क डन ड्यू टू फोर्स F1 पूछा गया है, तो ऑब्वियसली जवाब में हमें सिर्फ और सिर्फ F1 लेना पड़ेगा. Got it? So I hope all of you got this. Raise your hand. All of you got this? Okay, chalo. Awesome. Right? So let us talk about the concept of angular momentum first. Okay? Right? Let us talk about the concept of angular momentum first. Now, before talking about angular momentum, right, I would just ask about linear momentum. Let us see how many of us can recall the concept of linear momentum. Right? So, yeah, screen was paused. Maurya, if F1, F2, right, think about it, now F1, F2 equal नहीं है तो zero होगा क्या? Tell me. And कोई information दिया हुआ है क्या कि F1, F2 क्या होगा? नहीं ना? So how can we say, wait, something happened, my bad. So how can we say that F1 minus F2 will be zero? Got it? Right, Maurya? Okay. Now, right, so we will start the concept. Today's concept is angular momentum. Angular momentum, right? है ना? Angular momentum. Okay. Now, before talking about angular momentum, let us try to remember again the basic formula, try to relate to linear momentum. Then we will talk about the concepts. Okay. Now, when you talk about linear momentum, it is represented by P. Linear momentum is represented by P. Can anyone tell me what was the formula of linear momentum? Right. I guess most of you might know. Right. Most of you might know already. Tell me. I just want you to answer. Very good, Pragna. Very good, Ananya. Mass into velocity. Very good. Right? Mass into velocity. No one is having any issue in that. So it is mass into velocity. Correct. Correct. Mass into velocity. Now, before talk, I'm not writing anything. I'm just asking. Right? Before writing, I'm just asking. Okay. Now, if you talk about the analogous of mass in rotation, what is that physical quantity? What is a physical quantity? I'm not talking about the conceptual point of view. I'm just talking about some common sense point of view. Okay, याद कर सकना है क्या करना है all these things. Moment of inertia, yes or no, sir? Moment of inertia, we know that, right? Okay, awesome, awesome. And what is the analogous physical quantity for velocity in case of rotation? Omega, angular velocity. Very good, very good, right? Very good. Now, anyone have any doubt in this? Like ये तो सबको पता होगा ना, हाँ या ना? ये सबको पता होगा, right? Yes. So now I'll write. Now I'll write. Okay, just give me a minute. Okay. So I can say, sir, angular momentum was given by mass into velocity. So it's a physical quantity. It's a physical quantity which is the product of mass into velocity. Now, when you talk about angular momentum, it's written by L. So obviously, if we try to just use our common sense, right, we try to relate the parameters of linear momentum, right, and the rotational one, I can say, sir, logos of mass is moment of inertia I, and logos of velocity is omega. So this should be the formula. Yes or no? This should be the formula. I'm not saying is it this will be formula or not, but this should be the formula. Yes or no? Tell me, right? Even if I don't remember, if I use the basic concept, right? So ये तो होना चाहिए sir, है ना? Right? Yes, this is the formula. No, it is not. What is the formula then? Right? So actually, this is not the formula. है ना? Okay, this is not the formula. Then what is the formula? So formula is MVR. Okay, right? So formula is MVR. ठीक है. So MVR तो मास के टर्म में हो गया ना. ये हो गया कि कोई पॉइंट ऑब्जेक्ट है. Think about it. कोई पॉइंट ऑब्जेक्ट. This is a point object. We will see that this is correct or this is correct, right? So suppose we have a point object. Okay. Now if a point object is rotating, think about it. If a point object is rotating around one axis, this is axis. Okay, think about it. Everyone, step by step. A point object is rotating around this axis. है ना? Suppose, ठीक है, this is a point object, it is rotating around this axis. ऐसे rotate कर रहा है. Okay, right? Now if it is rotating around this axis, then the angular momentum L is given by mvr, right? But what about rigid body? What about rigid body? Tell me. What about a rigid body? I'm not talking about, I'm just trying to make you understand, right? है ना? अभी हम लोग ने start नहीं किया है. We'll see, we will derive everything. But मैं सोचने के लिए बोल रहा हूँ. If you talk about rigid body, can I use this same formula for rigid body? Rigid body, na Snigdha, rigid body, right? Sum of MVI is not for rigid body, right? It's a discrete system of mass, right? I'm talking about rigid body. जैसे नहीं ना? Yes or no? Because when you talk about rigid body, right? When you talk about rigid body, yes. Okay. So rigid body will rotate along its axis, but when you talk about rigid body, the mass is variable from each and every point. Mass is variable. Yes or no? Yes or no? Tell me. Raise your hand. Yes or no? Yes. Okay, correct. Very good. So can I say, sir, this will be the formula? No, this will not be the formula. Yes or no? This will not be the formula. So I can say, right, sir, these two formulas are correct. दोनों सही है सर. But depending on कि आप ले क्या रहे हो, है ना? आप ले क्या रहे हो? आप rigid body ले रहे हो कि आप एक mass ले रहे हो जो एक axis के around rotate कर रहा है. ठीक है? Got it? Yes or no? Got this? अभी हम लोग स्टार्ट कर रहे हैं, बस बेसिक समझाने का ट्राई कर रहे हैं, सिर्फ बेसिक समझाने का ट्राई कर रहे हैं. Okay, chalo. Now when you talk about, yes, now let us see. Okay, I is moment of inertia ना अंकित. I क्या होता है? I is moment of inertia, right? I is moment of inertia. Okay, now अब let us try to see कि भाई ये फॉर्मूला आया कहाँ से, क्या फॉर्मूला, एक्चुअल फॉर्मूला क्या है. This is not the actual formula, right? This is the simplified one, this is the simplest formula. Okay, now okay, now when we talk about linear momentum, so we know that when we talk about a mass, right, a mass which moves in a straight line, okay, right, then it will have a linear momentum which is represented by p, and the formula is m into v. And in the same way, right, if mass, right, of it, if any object is rotating, right, about some point or about some axis, you know, right, there must be some momentum associated with the rotation also, right? If we try to understand what is rotational, right, what is angular momentum, yes or no, don't you think? समझ में आता है कि नहीं आता है ना? Right, that if there's a mass and if it is rotating around some fixed point or an axis, there must be some momentum associated with that, right, associated with that rotational motion. And that, this is the definition I'm talking about, you know, this is the definition I'm talking about. And that rotational momentum is called your angular momentum. Yes or no? Right? Okay. Now, when we talk about angular momentum, as I said, we can have angular momentum based on two things. First, right, angular momentum right, of a particle, right, about a fixed point, Okay, so as I said, right, when you talk about this, about a particle, right, you know, linear momentum of a particle around a fixed point, so it is written by L, and this is given by R cross P. Okay, now what is this R, guys? What is this R? What do you think? What is this R? ये R क्या होगा? This R is the distance, right? This R is the distance between the point, fixed point of rotation and the object. Yes, not radius, ना. हाँ, मतलब अगर ये rotate करे तो circular orbit बन रहा है, उसका radius. You can say like that, right? And what is P? P is your angular momentum. So P is your linear momentum, right? P is your linear momentum. If you see that, so it will be R cross P is mass into velocity. Now here mass is a scalar quantity, yes or no? Mass is a scalar quantity. Makes sense? Yes or no? Yes or no? Right? So if mass is scalar quantity, can I say that mass को मैं बाहर ले लूँ तो क्या हो जाएगा? R cross V. Yes or no? Tell me yes or no. ये समझ में आ रहा है सबको? Right? So I can say that, okay, sir, if you talk about any random angle theta, because this is given by M VR sine theta n cap. Yes or no? Because this is the formula for cross product. Yes or no? Yes or no? Right? So what is V sine theta? Can I say that? Okay, sir, if I'm having a point, and suppose this is a particle, right? So this is the distance R, this is the distance R. Again, and suppose the velocity is like this, okay, and this angle is theta, So can I say, sir, this velocity have two components? Yes or no? This velocity have two components. One is this, okay, wait. One is this component along the radius and one is perpendicular component, right? This. So this is v cos theta and this is v sin theta. Now tell me, which component is responsible for angular momentum? Which component is responsible for angular momentum using the formula? Tell me. Which component? Sorry guys. Which component? So, Lohit, what is happening? Perpendicular component, yes or no? Because it is v sin theta. Perpendicular component. Now, अगर तुम logically सोचो, don't you think that sir, this is along the radius, right? It has nothing to do with rotation, right? It has nothing to do with rotation. But if we talk about this point, it is moving in this direction, right? If it's moving in this direction, the perpendicular component along the distance, right, is responsible for angular motion. Yes or no? So it is responsible for angular momentum. If you see the formula, it says the same thing, right? V sine theta into r, right, is the perpendicular component. Yes or no? Tell me yes or no. Tell me, समझ में आया सबको? Okay, very good, very good. Now this is for what? This is for particle about a fixed point. Now if we talk about second, if we talk about angular momentum, है ना? Think about it. Angular momentum. Just give me a minute, guys. Yeah, angular momentum. Some issue with the alignment. Okay. Of a rigid body. Of a rigid body, right? Now, when you talk about rigid body, there's axis of rotation, है ना? So it is about fixed axis. Fixed axis. Now, when you say this, अब यहाँ पे तुम्हारी बात आ गई इंटीग्रेशन की, है ना? जिस तुम लोग बोल रहे थे, अब यहाँ बात आई वहाँ इंटीग्रेशन की या तुम्हारे summation की. So can I say that, okay, suppose I'm having a rigid body like this. Suppose I'm having a rigid body like this, and the axis of rotation is this. Suppose this is axis of rotation. So when you talk about rigid body, it is made up of countless masses, right? Countless masses. I'm saying, like, suppose this is m1, this is m2, and this is a distance of r1, this is a distance of r2, right? The velocity will also be different, yes or no? So if you talk about individual particle, what is the linear momentum of, sorry, what is the moment of individual particles? Tell me, individual particles. Since it's moving around the axis, the velocity is always perpendicular to r, right? So this sine theta is always 1, right? Sine theta is always 1. Now, if sine theta is 1, if r is perpendicular to v, then L is given by mvr, right? Right? So यहाँ पे क्या हो जाएगा? It will be m1 r1 v1. L1 is equal to, now when you talk about countless objects, so I can say, sir, L total is given by summation of mi ri vi. Yes or no? Hi Anna. Yes or no? And we know that, we know one thing. What we know, sir, if it's a rigid body, it will have same angular velocity, same omega. Yes or no? So for any object, right, at distance of r1, r2, we can say that velocity vi is given by what? Ri into omega. Hi Anna, can I say that? This is something that we already know, right? Yes or no? This is already something that we know. Tell me. Yes, very good. So can I substitute this value in this? Can I substitute this value? Tell me. Yes, sir, I can substitute. So what it would be? So it would be summation of mi ri into ri omega. Now we know that, sir, ri into ri is ri square, but omega is a constant, right? Omega constant तो बाहर आ जाएगा. So L is given by omega summation of mi ri whole square. Now what is this value? ये value क्या होता है? What is this value? This term is called as, Bhavna, tell me what is this term called as? Sampada, Joel, Jaita, moment of inertia. Got it, correct. So can I say that, sir, this become I omega? I hope all of you understood this. So दोनों फॉर्मूला समझ में आया? दोनों फॉर्मूला सही है? Right? But ये जो है, ये जो फॉर्मूला है, it gives only the magnitude, yes or no? Right? It gives only the magnitude. डायरेक्शन के बारे में कुछ बता नहीं रहा ना हम लोग, यहाँ पे क्या किया, डायरेक्शन को हम लोग इग्नोर कर दिए, yes or no? Right? So generally ये डायरेक्शन, when you talk about direction, so डायरेक्शन जनरली रिजिड बॉडी का हम देखते हैं इसके रोटेशन के हिसाब से, ओमेगा के हिसाब से, राइट? ओमेगा का जो डायरेक्शन होता है वही एल का डायरेक्शन होता है. समझ में आया? जनरली. गॉट इट? ओके, राइट? चलो, सो यहां तक सबको समझ में आ गया? ये बेसिक समझ में आ गया? सबको ये बेसिक समझ में आया, हाँ या ना? ओके, चलो, वेरी गुड, वेरी गुड. सो एक यहां तक अगर समझ में आ गया, यहां तक अगर समझ में आया तो कुछ बेसिक प्रॉब्लम सॉल्व किया जाए. बहुत बेसिक. Okay, now, yes, so let us see this problem. Let us see this one basic problem. छोटा सा प्रॉब्लम देखते हैं. ओके, बताओ सब इसका जवाब देंगे यहाँ पे पॉल में, सबको जवाब देगा? कैन यू सी द पॉल? राइट, है ना? जवाब देगा यहाँ पे. स्टेप बाय स्टेप, ओनली 2 आंसर्स टिल नाउ. क्या लगता है? ओके, ओनली 8 आंसर्स टिल नाउ. बाकी लोग डंबल नहीं पता, जो बॉडी बिल्डिंग के लिए यूज करते हैं, राइट? दैट इज योर डंबल ना, राइट अंकित? Okay, so let us see, right? How many have answered? 10. So I hope all of you understood this problem, right? Hota kya hai? A woman holding dumbbell in her arms spin on rotating stool. Okay, assume that stool has no frictional torque, right, acting on the axis of rotation. When she draws the dumbbell inwards, ये हम लोगों ने कल ही देख लिया था. Yes or no? कल ही देख लिया था, right? कल देखा था. और हम लोगों ने ये थोड़ा सा डिस्कस भी किया था कि अगर हाथ बाहर फैला के रखे हो और हाथ पास में कर लिया तो क्या होगा? याद आ रहा है किसी को? याद आ रहा है? टेल मी, याद आ रहा है कि नहीं याद आ रहा है? हाथ वाला प्रॉब्लम, राइट? सो let us see the answer. So most of you say that it is A. Do you still want to change your answer? The answer is A, right? Why? Tell me why. Now think about it. Will there be any external torque? अब खुद सोचो एक बार, एक चीज सोचो. When you talk about this angular momentum, है ना? When you talk about angular momentum, right? It is constant. This is not changing. Yes or no, right? Because if there's no extra torque, this is constant. We will discuss this, right? This is constant. Now, if this is constant, right? And if you are using dumbbell, what is changing? Tell me what is changing. I is changing. We know, right? When you talk about kinetic energy, potential kinetic energy, right? So translation kinetic energy, है ना? Translation kinetic energy formula क्या था? P square by 2m था. Yes or no? Raise your hand. P square by 2m था. mv square, right? है ना? So in the same way, when you talk about rotational kinetic energy, which is also given by L square by 2I, right? Now, if you draw your hand inward, I will decrease. Yes or no? Moment of inertia कम हो जाएगा ना? Yes or no? Because R will decrease, right? Yes or no? So if moment of inertia will decrease, right, then kinetic energy will increase because it is in denominator, because the angular momentum will be constant. Yes or no? हाँ या ना? Tell me. समझ में आया? हाँ या ना? Tell me. Yes. So I hope all of you got this conceptual problem. Okay. Now think about it. This one. This is also related with that dumbbell problem. Okay, you can just answer in the poll. Everyone can just answer in the poll. Okay, one answers. Two answer. Guys, think about it ना. अभी हम लोगों ने डिस्कस किया, थोड़ा सा इसमें कोई कैलकुलेशन नहीं है, बस कॉमन सेंस सोचना है, सिर्फ कोई कैलकुलेशन नहीं है. Tell me guys, everyone tell me. Only 7 answers till now. 8. ये तुम लोग इमेजिन भी करके बता सकते हो क्या होगा इसका आंसर, राइट? क्या क्या ऑप्शन दिया हुआ है? हर एंगुलर वेलोसिटी डिक्रीजेस. सेकंड ऑप्शन, so second point, her moment of inertia about the axis rotation decreases. ये दो पॉइंट्स हम लोग अभी डिस्कस किए थे. Then her angular momentum around the rotation axis decreases. अरे स्पिन कर रहा है ना, रोटेटिंग मतलब क्या है? स्पिन कर रहा है, हाथ में लेकर गोल गोल घूम रहा है. एक जैसे मान लो यहाँ पे कोई एक है, राइट, प्लेटफॉर्म, और ये हाथ में ऐसे लिया हुआ डंबल, राइट, है ना, और ये घूम रहा है गोल गोल. गॉट इट? इमेजिन क्या करना है इसमें? जैसे मेरी गो राउंड में कैसे आगे घूमते हैं, मेरी गो राउंड में देखे हो कभी घूमते हुए? यस और नो? राइट, बचपन में मेरी गो राउंड में घूमा है कि नहीं? वैसे ही, राइट, सिंपल. ओके, नाउ टेल मी which of the following is correct. Tell me. Think about it. Her angular velocity decreases. सही है गलत है? बताओ, सही गलत है, क्या लग रहा है? Wrong. Okay. Second, her moment of inertia about the axis of rotation decreases. सही है गलत है? This is correct. अभी मैंने बताया ना, yes or no? Right, true, correct, very good. Third, angular momentum about the rotation axis decreases. ये भी मैंने अभी बताया. Wrong, right? Very good, है ना? then angular momentum increase and angular velocity increases. Now this is also true. Speed बढ़ जाता है ना, हम लोगों ने डिस्कस किया था. So answer should be what? D, right? Yes or no? Second or fourth? D. Clear है? So most of you gave the correct answer, right? Most of you gave the correct answer. 9 of you gave correct answer. Okay, very good. So ये सबको समझ में आ गया? Tell me, सबको समझ में आ गया? Yes or no? Basic concepts, basic concepts. Okay. ओके चलो अब आते हैं नेक्स्ट. यहाँ तक किसी दिक्कत है? यहाँ तक किसी दिक्कत है? बेसिक समझ में आया कि मोमेंटम हो क्या रहा है और. Now let us again try to relate, right? Again try to relate these terms. Okay. So when you talk about force, anyone remember the second law of Newton, second equation of something happened? Wait. How many of you remember? How many of you remember Newton's second law? Tell me, what was Newton's second law? F net is equal to what? F net is equal to what? It's not MA. F net was dP by dt. Yes or no? Very good. Very good. Awesome. Correct. Correct, Pragna. Now, don't you think, sir, if F net is equal to dP by dt, what should be tau net? Tell me. What should be tau net? Correct, Sampada. It is dl by dt. Very good. dl by dt. Awesome. Okay. Now, let me ask you one thing. Right? If you talk about, sir, F net is equal to dP by dt and tau net is equal to di by dt, this is equal to MA. And this is equal to what? I alpha. Yes or no? Yes or no? Right? Yes. So now this is the basic definition. So if you talk about this, we know that, sir, if you talk about this, dP is equal to what? MA dt. So if we integrate both sides, we got P is equal to mv, because mass is constant, ADT will give you velocity, or basically delta P is equal to what? M delta V. Yes or no? Hi Anna, raise your hand. Right? In the same way, don't you think, sir, dl is equal to what? I alpha dt. So integration of dl will give you integration of I alpha dt. So delta L will give you what? I. Now what is alpha delta t? Alpha dt. This is equal to delta omega. Hi Anna. Tell me yes or no. Raise your hand. Yes. Right? So I will just write down all the information that I can get right from this. So this is first information. Anna. Okay. Next. Okay, sir, I understood this, right? I understood how the formula is obtained and all those things. Now let us try to relate. Now, when you talk about torque, what is torque, guys? Torque is equal to what? R cross F. Yes or no? Yes or no? Right? Yes, sir. I know, sir. I understood, sir. This is something that we have already studied, sir. Okay. So I can say, okay. Now torque is equal to, what is R? Sir, R is R only. But what is F? Sir, F is dP by dt. Yes or no? Yes or no? And what is torque? Sir, torque is equal to dl by dt. Yes or no? Any issues in this? Any issues to this point? Raise your hand. Any issue in this till this point? No, right? I assume no. Okay, now. Okay, so I'll take this differentiation outside. So I will just write like this: d r cross p by dt. Can it be written as dl by dt? Yes or no? Yes or no? Tell me. Yes or no? Yeah, suppose right. So can I write like this, sir? R cross p is equal to L. अब समझ में आ गई भाई ये फॉर्मूला कहां से आ गया? Yes or no? Right? Yes or no? Did you get this? Right? Or R cross mv is equal to L. So m R cross v is equal to L. Yes or no? Tell me. All of you got this? ये second point कि जो formula था मेरा वो derive कहाँ से हुआ? Any issues in this? Any issues in this? Raise your hand. Any issue in this? No, right? Don't worry. I'll just cover a small concept, small topic, है ना? Right? ज़्यादा time नहीं लूँगा मैं. धीरे धीरे. ठीक है. यहाँ तक सबको समझ में आएगी नहीं? Tell me. समझ में आ रहा है? मैं क्या बोल रहा हूँ? अनन्या, अंकित, भावना, जयल, जयिता, विवेक, कौशिक, अभिलाष, नेहा, प्रवलिका, श्रीकर, सुहान, यशिका, यश. Okay, nice, very good. Now, as I told you, always try to relate your translation motion with rotation motion. बहुत concept clear रहेगा हमारा. ठीक है. तो make a two table over here, right? Let us try to make a table. Translation. And here we have rotation. Okay. I'll send the recording to Sampradha. I'll send the recording. Don't worry, right? Now, when you talk about translation, sir, F is equal to MA, which is equal to M. Tell me, delta V by delta T, which is equal to dP by dt. Okay. Now, when you talk about rotation, sir, tau is equal to I alpha. This is equal to I delta omega by delta T or dl by dt. Right? Now, if f net is equal to 0, sir, then delta mv is equal to 0. Yes or no? Right? Or I can say, sir, delta p is equal to 0. High enough. Right? Means the momentum is conserved. Right? I say linear momentum is conserved. Is conserved because there's no external force, right? There's no external force. No external force. Yes or no? Yes or no? यहाँ तक हमको सब कुछ में आता था हमको ऑलरेडी पता है. सही है तो है ना? इतना तो पता है, हम लोगों ने क्लास 9th में पढ़ा था. Okay, now tell me in this, if I'm saying, sir, tau net is equal to 0. Now you tell me what all can we write? What can we can conclude? What can we can imagine? Tell me. अगर torque 0 है, will there be any angular acceleration? Tell me, will there be any angular acceleration? Tell me. No, right? No, there will not be any angular acceleration. Right? Correct. Very good. So I can say, sir, dl should be equal to 0, or not just dl, actually delta l should be equal to 0. Right? So can I say, so in this case, angular momentum is conserved? Yes or no? Because when you talk about delta L, what is delta L? So it is L final minus L initial is equal to 0. Yes or no? Yes or no? Tell me. Because here it was what? P final minus P initial, and it was equal to 0. Right? So that means P final is equal to P initial. Means initial momentum is equal to final momentum. In the same way, here I can say LF is equal to LI. Means initial angular momentum is equal to final angular momentum. Tell me, anyone have any doubt in this? Anyone have any doubt in this? Anyone have any doubt in this? Right? Now, my question is, okay, where it will be used, right? We have used this in multiple ways, strike jab karta, collision and all. Now, let me ask you one problem. Suppose you talk about one object which is moving in this elliptical path around this point, suppose, right? Okay, and there's no external force. Now, do you think that the momentum of this object at this point A and the momentum of this object at point B will be same? Yes or no? Tell me. L will be same or not? L will be same. Tell me, will L be same? Yes or no? My bad. Okay. Remove this. Okay. Just give me a minute, guys. Something happened. Yeah. L will be same, right? Yes, magnitude wise only. Magnitude wise. Magnitude wise. I'm talking about magnitude wise. Yes. Because here we talk about magnitude. यहाँ पे magnitude की बात कर रहे हैं, है कि नहीं? Magnitude की बात कर रहा हूँ. Magnitude will be same. But what about omega? Will omega be same? Will omega be same? Tell me, will omega be same? Or will I be same? Will we be same? No, right? Got it? Because sir, यहाँ पे जो है वो distance ज़्यादा है, यहाँ पे distance कम है. So I will keep on changing. So as I will keep on changing, omega will also keep on changing. We will also keep on changing. But at any point, the angular, tell me, momentum will be constant. The angular momentum will be constant. Same. Got it? Everyone got this? Raise your hand. Everyone got this? सबको समझ में आया मैं क्या बोल रहा हूँ? Yes or no? Yes or no? Right. Yes. Very good. This is the last problem of today's class. मैं बहुत छोटा class लूँगा because toppling we will cover in next class. Toppling में आज नहीं पढ़ा रहा. मैं basic एक concept करवा रहा हूँ. ज़्यादा हचपच ना हो, है कि नहीं? सिर्फ एक concept. Now tell me, इसके लिए what do you think? इसका क्या होगा? Yes, ठीक है. I'll just show it at the last. Don't worry. I'll show it at the last. ये सोचो पहले ये क्या होगा? Think about it. Think about it, guys. Think about it. If you place the ring on the disc, right, will there be any external force? What would be the force between these two? Tell me, what would be the force between the ring and the disc? Tell me, ring और disc के बीच का force कौन सा होगा? Tell me, it will be frictional force, no? It will be frictional force, right? Yes or no? So I got only 5 answers. I'll just end the poll. Okay. So people are still confused on this because you're not thinking, right? Think about it now. Now tell me this. If you drop the ring on the disc, right? If you're dropping it, will there be any external force between the ring and the disc? Tell me. No, there's no external force, right? Yes or no? So F क्या हो जाएगा भाई? F क्या हो जाएगा? F 0 हो जाएगा. Yes or no? Simple. F 0 हो जाएगा. Right? Because there will be frictional force, and frictional force between the ring and the disc is internal force. दोनों के बीच के कारण हो रहा है ना? Right? But what about torque? So torque 0 नहीं होगा sir. Yes or no? समझ में आ रहा है? Yes or no? Okay, so just go through it. Ring is placed on rotating disc. Kinetic energy, kinetic friction क्या होगा? Start oppose करेगा उसको, है कि नहीं? Right? Okay, but net force क्या होगा? 0. Yes or no? Because it is internal force. When I am talking about net force, it is external ना. जो ring पे लगाएगा disc ring पे उल्टा लगाएगा. Okay, right? Yes or no? Yes or no? But because of this kinetic friction, they will be torque in opposite direction, right? Sorry, they'll be torque in same direction. Yes or no? Because the direction of kinetic friction, if you think about it, you have to imagine करना. ये ऐसे है और ये ऐसे है, राइट ना, अगर ये ऐसे रोटेट कर रहा है तो इस पे इसकी टेंडेंसी क्या होगी, रिंग की टेंडेंसी होगी, अगेन सूडो फोर्स कॉन्सेप्ट आ रहा है, रिंग की टेंडेंसी होगी पीछे जाने की, है कि नहीं, राइट, सिंपल फर्स्ट लॉ ऑफ इनर्शिया, बट फ्रिक्शनल फोर्स के कारण इट मूव्स इन दिस डायरेक्शन, रिंग विल आल्सो रोटेट इन दिस डायरेक्शन, yes or no? So according to kinetic friction, the ring will rotate in this direction, and the torque because of this will also increase in this direction, yes or no? The direction of the particular hoga, but since these two forces are additional in nature, the torque will be added, yes or no? So the torque will be added, it will speed up, yes or no? It will speed up, moment of inertia बढ़ जाएगा पूरे system का, right? So obviously torque is not constant. समझ में आ गया? Tell me, everyone got this? Everyone got this? Tell me yes or no. Yes or no. Right? Okay. So I hope all of you understood this basic theory.